Bismillahirrahmanirrahim. Assalamu alaikum 7th class. Today we will start our third chapter, the periodic table. In this chapter we will learn about atom, its structure, subatomic particle of atom and the contribution of different scientists in the discovery of structure of atom. Atom is very small particle, so it is very difficult to imagine anything as small as an atom. 100 millions of them side by side could only measure about 1 centimeter across. Despite this, scientists have been able to find out a great deal about atoms. Scientists currently believe that an atom consists of a dense nucleus surrounded by a cloud of negatively charged electrons. The nucleus contains positively charged proton and electrically neutral neutrons. So here is a theoretical model of atom. You can see in the center there is a nucleus which contain positively charged proton and neutral neutron. These two structures form the nucleus, and then you can see the round circle which is known as the shell, in which electrons which are negatively charged are found. Overall, atom is a neutral particle. There is no charge on atom because in the atom there is same number of proton and electron and neutron is present. So atom is a neutral particle. Scientists have taken over 100 years to produce this atomic model and work is still going on. Below are some of the scientists who have made important discoveries about the structure of an atom. John Dalton, the era was 1766 to 1844, was the first scientist who worked out that everything was made up of atoms. Dalton found out that water could only evaporate into the air if waters and air were made up of particles that could mix together. Dalton then had the idea that everything is made up of particles which could not be broken down into anything smaller. He called this particle atom. Dalton also thought different atoms had different weight and did experiment to prove it. Joseph John Thomson, the era is 1856 to 1940, had the idea that there were particles even smaller than the atom. Using a cathode ray tube, Thomson discovered the existence of the subatomic particle electron. In the Thomas atomic model, most of the space in an atom is made up of positively charged material with lots of tiny negatively charged electrons scattered around it. According to the atomic model of Thomson, positive material is like a pudding and electrons are embedded into it. Ernest Rutherford, era is 1871 till 1937, studied with J.J. Thomson at Cambridge University in England. In 1911, Rutherford fired a beam of positive particle against thin gold foil, expecting them all to pass straight through. However, some particles were repelled. Since positive particle can only be repelled by something positive, as you know that always same charge repel each other, Rutherford decided these must be a positive bit in the center of each atom. Also, this positive bit must be very small, otherwise most of the particle would not have got through the gold foil. Rutherford's atomic model therefore had a tiny positively charged nucleus with electron whistling or moving about in the space around it. As you can see in this the experimental diagram of Rutherford, there is a hard nucleus inside which is a positive particle and the beam of electron is reflecting from it. It is a gold atom and positive particle mostly passes through from the empty spaces. Niels Bohr, era is 1885 till 1962. Bohr and Rutherford developed the atomic model further by suggesting that electrons orbit the nucleus at high speed in fixed orbits around the nucleus. The Rutherford-Bohr atomic model helps us to explain the periodic table. Chemical symbols. Each element has its own unique symbol, a sort of chemical shorthand recognized all over the world, because normally when we write some elements we can use the symbol of it. A chemical symbol can be a capital letter, for example C, which is the symbol of the element carbon, or a capital letter followed by a lowercase letter, for example for calcium the symbol will be C and A, which comes from the first two letters of its English name. Iron on the other hand has the symbol Fe, which comes from the Latin name ferrum. Other elements have symbol made up from their first letter and one letter in its name, and this letter could be any. Magnesium, Mg, and zinc, Zn are example of these. Atomic number. Atomic number tell us about the number of proton present in the nucleus. The number of proton in an atom is called its atomic number. Each element has a different atomic number. Elements contain neutral atom. Basically, atoms are neutral. It contains the same number of electron and proton. Since protons are positively charged particle, there must be an equal number of negatively charged electrons. So the atomic number also tell us how many electrons the atom has. Mass number. Protons and neutrons have approximately the same mass. Electrons have a mass so small it can be ignored. The mass of an atom depends on how many protons and neutrons it has. So you can see in the equation mass number is equal to the number of proton plus number of neutron. All carbon atoms have 6 proton in the nucleus. This carbon atom has 6 proton and 6 neutron, giving a mass number of 12. We can calculate the mass number of any atom by calculating the number of proton and neutron in it. The mass of electron is so small, so we ignore it. The arrangement of electrons. Bohr and Rutherford worked out a theoretical model for an atom in which the electrons are arranged in layers around the nucleus. Each layer or shell can hold a certain number of electrons. The first shell, called the K shell, can hold a maximum of 2 electrons. The second shell, called the L shell, can hold a maximum of 8 electrons. And the third shell can hold up to 18 electrons, which is known as M shell, but is stable at 8. The electron built up from the first shell, filling each one until all the electrons are in place. This means all the atoms are so close to the nucleus they can be. The table shows the electrons are arranged for the first 10 elements. In this table you can see 6 headings. First, the name of element, then symbol, atomic number, number of electron, first shell, second shell. Element hydrogen, symbol is H, atomic number is 1, number of electron is 1, first shell contains 1 electron and in second shell there is no electron. Helium, symbol is He, atomic number is 2, number of electron is 2, first shell contains 2 electron and the second shell contains no electron. Lithium, Li, atomic number 3, number of electron is 3, first shell contains 2 electron, second shell contains 1 electron. Beryllium, Be, atomic number is 4, number of electron is 4, first shell contain 2 electron and second shell also contain 2 electron. Boron, B, atomic number 5, number of electron 5, first shell contain 2 electron and second shell contain 3 electron. Carbon, symbol is C, atomic number 6, number of electron is 6, first shell contain 2 electron and second shell contain 4 electron. Nitrogen, symbol N, atomic number 7, number of electron 7, first shell contain 2 electron and second shell contain 5 electron. Oxygen, symbol O, atomic number 8, mass number number of electron 8, first shell contain 2 electron, second shell contain 6 electron. Fluorine, symbol F, atomic number 9, number of electron 9, first shell contain 2 electron, second shell contain 7. Neon, symbol Ne, atomic number 10, number of electron 10, first shell contain 2 and second contain 8. The maximum number of electron that can occupy a shell is equal to 2n square, whereas n is equal to the number of the shell. For example, in the second shell n is equal to 2, so 2n square is equal to 8. periodic table. The periodic table displays 118 elements in the order of their atomic number. The table has several horizontal rows called periods arranged on top of each other. As a result, elements with similar properties are arranged in vertical column called groups. The zigzag line at the right hand end of the periodic table divides the metals and non-metals. Notice that hydrogen is outside the main table. It doesn't fit in any particular group. Elements within each group share similar properties. The groups are numbered starting at group 1 on the left hand side. The group number is the same as the number of electrons in outermost shell. The number of electrons in the outer shell of its atom has a big effect on the way an element reacts. That is why elements in the same group of the periodic table tend to react in the same way as each other. A full outer shell is a very stable arrangement. Elements with full outer shell are very unreactive because the electrons tend to stay where they are. However, elements with one electron or with one space in their outer shell are very reactive. The elements in group 1 are called the alkali metal. All alkali metal have one electron in their outermost shell. The elements in group 2 are called the alkaline earth metal. All elements of this group have two electrons in the outermost shell. On the right hand side, group 3 includes elements which have 3 electrons in their outer shell. Group 4, known as carbon family, all the elements in this group have 4 electrons in the outermost shell. Group 5 is known as nitrogen family. All elements have 5 electrons in their outermost shell. Oxygen and sulfur are the main element of group 6. All the elements of this group have 6 electrons in their outermost shell. Group 7 of the periodic table contains the halogens. These are reactive elements because their atom have one empty space in their outer shell. Halogens are colored gases and very poisonous. Perhaps the most famous group in the periodic table is group 8 or group 0, the noble gases. They are famous because they do not react. This is because their outer electron shell are completely full. Halogens, such as bromine, are colored poisonous gases. They are very reactive. Helium is used to fill balloons because it is lighter than air. Helium-filled balloons float upward and they are also safe to use. This is all about today's lecture. Hopefully you have learned about periodic table in detail. If you find any difficulty, you can ask me. Thank you.